My dear students, now I am taking third part of chapter second, 11th class. That is functions. In first part, we have learnt Cartesian product. In second part, relations, and third part, functions. This is a very important topic, and I am going to define it. A relation from a set A to B is said to be a function if every element of set A has one and only one image in set B. This is the definition of the function. My dear students, in second part, you have seen so many relations, but all the relations were not functions, because every element of set A should have a distinct image or a image in set B. Condition is that every element of set A should have a one and only one image in set B. This is the condition. So, in other words, a function f is a relation from set A to B, and no two distinct ordered pair in f have the same first element. It means, according to this, if you have a function and then find out the domain of that function, there should be no repetition on domain. This is the meaning of this. No element should be repeated in the domain. So, therefore, in second definition, we have to find out the function of the domain. We have to find out the domain of a function, and we have to see whether there is any element which is repeated. If not repeated, then that is function. So I am giving you example, and by the with the help of the example, the concept will be clear to you. There is a relation. R is a relation. I am writing this relation. 1, 2, 2, 3, 3, 4, and 4, 5, 5, 6. This is a relation. And with the help of the diagram C, is 1, 2, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, and 6. 1 has a image 2. Image of 2 is 3. Image of 3 is 4. And image 4 of 5. And image of 5 is 6. In this pair, 1 has image 2 in B. 2 has image 3 in B. 3 has image in 4 in B. These are the ordered pairs and defines the elements of set A and elements of set B, and with the help of this diagram we will see whether this relation is function or not. According to the definition, all the elements, and you can say all the distinct element, 1, 2, 3, 4, 5, all the element of this set. Suppose this is A and this is set, suppose this is also A. All these elements of this set have images in set, another set, this A. And all the images are also distinct. This, see here. So every element of A has one and only one, not two. One and one. One has only one image. Two has only one image. There should be no two images. So this is a function. Condition, two conditions. Every element of A. Second condition, should have a one and only one image in B. Here, these 5 elements have 5 different images in second set. So this is a function. Now, again, I am taking next example. I have taken a example in part second. What was that? XY relation such that x was a relation such that x y is equal to x plus 1. This was the example in part first. And the relation was, we have shown in the diagram, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1 has image 2. Here x is 1 and y is 2. Check this relation. If x is 1, y is 2. X is 2, y is 3. Yeah, put here 2, y is 3. And x is 3, y is 4. And x is 4, y is 5. And x is 5, y is 6. And this 6 remains without image. This was the example I have given in the part second. This was a relation, but this relation is not a function. Why? Tell me why? Because every element of this A, every element of A have no only one and only one image in B, because 6 is there. In every element, 6 is also. You can't say every element of A have one and only one image in B. 6 element has no image in B. So that according to the definition of function, this is not a function, only this is a relation. First condition fails here. Every element of A, not every. One element is there which has no image. So this is not a function, only this is a relation. Now another example. One example is also in the second part I have given. What was that? That relation was x, y such that x is a square of y. This was the condition. X is a square of y. And we have shown this relation by the diagram. Here 4, 9, 25. Here 1, 2, 3, 5. Minus 2, minus 3, minus 5. You see here, 2 has this plus 2 image and 2 also have minus 2 according to this condition, because square of 2 is 4 and square of minus 2 is also 4. So this 4 has 2 images, 2 and minus 2, and 9 also has 2 images, 3 and minus 3, and 25 also has 2 images. This was the second example in part second. See there, and you here see all the elements of A. This is right, covered. All the elements of A have images. This is first condition is right, but second condition was that these elements should have one and only one image, but it has two images. This also has two images. 25 has also two images. So the second condition is not fulfilled. So therefore, this is a relation. You see, this is a relation, but this is not a function. I think you have understood my point. According to definition, I have given so many examples to you. Now I am taking more examples. I will try to make the definition of function clear to you. Now I am taking example. Relation. I am taking this relation. What is this relation? 2, 1 and 3, 1 and 4, 2. This is a relation. And here 2, 1. 2 has a image 1. 3 has a image 1. 4 has a image 2. See here carefully. The image of 2 is 1, image of 3 is 1, and image 4 of 2. Every element of A, these are the element of A, 2, 3, 4. Every element of A, 2, 3, 4, and every element of B, 1, 1 to 1, 1, 2. This as a image, this 3 has 1 and 4 has 2. This is the image of 2 is 1, image of 3 is 1 and 4 is 2. This now see, tally the two condition. All the element of A, this is right. No element is left. Have images. And see there, all these elements have one and only one image. Yes, this has one image. 3 has also one image. 4 has also one image. Second condition is also satisfied. All the elements have images, and all the elements of A have one and only one image in B. Both the conditions are satisfied. Don't see here. Some student will think that 1 is the image of 2 and 1 is also image of 3. There is a repetition. Don't take this repetition. The condition is that this element have one image. This element has one image. This is the condition. One and only one image. There repetition may be. So this is a relation. Both the conditions are satisfied. This is a function. This relation is a function. Another example. I will try to make this concept very clear to you. I am giving you more example. Now there is a relation R. 2, 2. 2, 2, 2, 2, 4. 3, 3. And 4, 4. This is a relation. Now, this is image of 2. Image of 2 is 2. Image in this second pair, image of 2 is 4. Image of 3 is 3. Image of 4 is 4. Here, see the condition. This has one image. This has one image. But this 2, This is only 2. I have written 2 times, but this is only 2. And this 2 has 2 images. You can write it 2, 2 and 4. 2 images. Yes, write this. First condition is fulfilled. Every element of A has images. First condition is fulfilled. Second image, this 2 has 2 images. And condition is that every element should have one and only one image in B. And it has 2 images in B. Or by the diagram C. By the diagram you see 2, 2, 3, 4, 4, 2, 4, 3, 4, 2, 2, 3, 4. These are the images. Or you can write it again. I am write it again for your understanding. 2 write once, because I have said so many times there should be no repetition in the set of elements. Elements should not be repeated in set. So here 2 was 2 was repeated, so I write it once. So 2 has 2 images. This is the way of writing, correct way of writing. So here 4 has 1 image, 3 has 1 image, 2 has 2 images, 2 and 4. All the elements have images. The first condition is fulfilled. But second condition, all the elements should have one and only one image. But this 2 has 2 images. Second condition is not fulfilled. So this is not a function, this is a relation. So my dear students, I think the function is clear to you. The definition of the function is very clear to you, because I have given so many examples to you. There are 2 conditions. I am again repeat. There are 2 conditions of function. Every element of A should have image in B. This is the first condition. Second, every element of A should have one and only one image in B. Have image, that is another person. But one and only one image, that is the second question. So you have to check these 2 conditions. In any relation, if you find these 2 conditions fulfilled, then that relation is function. Otherwise, that relation is not a function. I think the concept is very clear to you, my dear student. This was the third part. In first part, Cartesian product, second part, relations, and third part, functions. And one more part of this chapter remains. I will take that part tomorrow. And in the last, I want to make a request to you. Please subscribe the channel. I shall be very thankful to you. Again, thanks.